Hi everyone, we are going to talk about transition metal as catalyst. Let's start by meeting our group members. First, we have AIZAFARINA, ELISA binti ROSLI, Izzah Mahfuzah HANIM binti ARSHAD, AHMAD MUKHLIS bin ROZA EFFENDY, BATRISYIA binti Muhammad AZAM, and lastly Muhammad HAFIZI bin JAFRI.
If you want to find the metal that we use every day, like gold, copper, nickel, and silver, you just need to look at the center of the periodic table. These are called the transition element, found in D block, located in group 3 to group 12. They are unique because of their partially filled d orbital. As you can see on this slide, I've listed out some general properties. They are hard and strong, they have incredibly high melting and boiling point, they are fantastic electrical conductors, they give us magnetism, and they can exist in variable oxidation state, which is why, for example, Fe2 plus can become Fe3 plus, and this often lead to the beautiful formation of colored compound. But out of all these properties, there is one that drives the chemical industry forward, and that is exactly what we are here to explore today, how transition elements act as catalysts.
So hi, I'm going to talk about the catalytic properties of transition element. Firstly, what is catalyst? Catalyst is a substance that speeds up the chemical reaction without being used up or permanently changed at the end of the reaction. So, the transition element is a good catalyst because they have variable oxidation state. Second, they act as a partially filled d orbital, and it also can absorb reactant molecule on their surfaces. But how do they really work as a catalyst? Let me tell you one by one. First, the transition metal will form temporary bond with the reactant. Then, this will weaken the existing bond in the reactant molecule. So, it will provide an alternative reaction pathway with the lower activation energy. Lastly, the catalyst will remain chemically unchanged after the reaction.
So now, let's look into how the properties of transition metal make them suitable as a catalyst. First is the multiple oxidation state of the transition metal. Transition metal has multiple oxidation state, meaning it can easily gain or lose electron. This means that transition metal can act as the middleman that hold and transfer electron to reactant. Transition metal can temporarily take electron from reactant and also donate those electrons to another reactant. This transfer of electron alter the electron distribution within the reactant bond, making it easier to form bond between reactant. And when all the reactant had react, the transition metal will return to its original state. Next is the absorbance of substances to transition metal surfaces. Because transition metal has a partially filled d orbital, it allows for a temporary bond to be formed with the reactant. For example, here we have a hydrogen molecule and an atom. Usually, the transition metal chosen for this reaction is nickel or platinum. Now, for a molecule to form or break bond, they would require energy. But by adsorbing to the surface of the metal, it breaks the HH bond of the hydrogen and weaken the pi bond on the atom, lowering the initial energy required to form bond between the two reactants. What's more, by adsorbing to the surface of the metal, the atoms are packed more closely together to allow for a more meaningful collision to form bond. After the bond between reaction is formed, the product would leave the metal surfaces, making it free to facilitate reaction for another reactant.
Now, we move on to the application of transition metal. First, we have electrochemical water splitting. Transition metals are used as a catalyst to help splitting water into hydrogen and oxygen. They lower the energy needed for the reaction, especially in the hydrogen and oxygen evolution reaction. Second is feature-structure synthesis, FDS. Cobalt is used as a catalyst to convert synthesis gas, which is carbon monoxide and hydrogen, into synthetic fuels such as diesel and jet fuels. Next, catalytic converters in vehicles. Transition metals help reduce harmful exhaust gases from vehicles. They convert carbon monoxide and hydrocarbon into less harmful substances like carbon dioxide and water. Lastly is Haber process. Iron is used as a catalyst in the Haber process to produce ammonia. The iron surface helps nitrogen and hydrogen react more efficiently.
In conclusion, characterized by their partially filled d orbitals and variable oxidation states, transition metals function as exceptionally versatile catalysts by providing an active surface for reactants to adsorb and form temporary bonds, a process that weakens internal molecular connections and orients reactants to maximize collision efficiency, thereby lowering activation energy for vital processes ranging from the industrial synthesis of ammonia and fuels to the environmental mitigation of vehicle emissions and the generation of clean hydrogen energy. And that is all.